Alright, so this is the video for part 1 of the Lab 3 aerospace experiments with Dr. Osprey. And we're going to be going over an analysis of an airfoil, a simplified airfoil. So I already have it kind of set up. I'm just going to go through what I did. So the first step is to make your CAD model. And from Lab 2, we already had the airfoil set up. So I just loaded that into Design Modeler, and then I made the airfoil shape here, which is just simplified as a circle with two lines dragging back. So the length of the airfoil is supposed to be 0.5 inches, which is just given to you, and the radius of the circle is supposed to be 0.18 times this length here, the chord length, which would give you 0.09 inches. And so just to make this, you make that first line, which is the length, and then you make a second line here, and then you make a circle with the center at this part, and then you just drag it out to this point, which is going to be the radius of that circle. And yeah, so after that, you want to make a line, a vertical line going through the center of the circle and just going outward. And then you can want to click on construction point at intersection, and then this is gonna allow you to select two different edges. So you want to click the circle edge and then the line that you would draw over here, and then it's gonna make a point at the top and it's gonna make a point at the bottom for you to eventually make two lines coming from that top point down over to the tail of the airfoil, and then one coming from down here up here. And then you can just kind of use the trimming tool here to remove any lines that you don't need. Like for example, when you make that circle, you're gonna have this side of the circle left over, so you can just trim that out, and you can have just a solid surface here, which you're gonna need to, because if not, it's gonna give you some errors. And that's pretty much how we do the CAD model. You can exit out of that, and then you're gonna have to right click on the mesh and update with the geometry that you just did. And then you want to open up the mesh. The mesh is pretty important because it's gonna be what your results rely on. So you want to right click on the mesh and you're gonna insert a method mesh, and then once you click on that, it's gonna give you this little menu, and you want to click on the geometry right here, and then you're gonna click on the airfoil. And then on the method, it's first gonna give you the option of quadrilateral dominant, and you wanna move that to triangles. And then you want to click on mesh again, and then set the element size to something really small. I put 0.12 or 0.0125 meters, which works fine in this scenario. You could make it smaller if you want. It's gonna give you more precise results, but for the case of this lab, I'm just gonna leave it at that. And then you want to right click on mesh again, and you want to insert an inflation mesh, and that's gonna set a specific boundary for the airfoil. So once you have that, it's gonna ask you for a geometry. In the geometry, you want to select the airfoil again, and then on the boundary menu, you're gonna click on that, and then you're gonna hold down Control, and you're gonna select this half circle here, and then the two lines, and then you're gonna click Apply, and then Generate, and it's gonna generate that mesh for you, and it's gonna look something like this. This is the method mesh out here, and then as you zoom in towards it, you're gonna have these kind of lines that go around the airfoil, and this is gonna be that inflation. And then after that, you wanna select here on edges, and then you're gonna wanna click on an edge and then press N, and then it's gonna give you this menu. You wanna name this this part right here, you wanna name it velocity inlet. And then the end of the diffuser, you want to name it pressure outlet. So you're going to click on it and then press N, and then you're going to name it that, and then hit OK. And then for the walls of the wind tunnel, you want to hold down Control, and then you want to highlight all the walls except the front and the back. You're just going to do the top ones and the bottom ones. And you're going to click N again, and then you want to type in, you can name this whatever. I named it tunnel walls. And then you press OK, I already have them named, so I'm not gonna rename them. And then you want to zoom in on the airfoil, and then you're gonna do the same thing that you did for the walls, but this time in the airfoil. So when I hold control, and then you want to highlight these two lines and then the circle, and then press N, and then you're gonna get this selection again. You can name that airfoil, you can name it whatever you want, as long as it's named, so that you can use it to get some results after. So at that point, you're just pretty much done with the mesh. You want to click generate, and then you're gonna exit out of here, and then you're gonna go on setup. You're gonna right click, you can click update just to make sure everything goes through, and then you want to double click on setup, and then it's gonna open up the fluent menu. You want to click double position because it's just gonna make your results better, and then you can click start. And just let it load. Alright, so as we can see here, we have that velocity going in, and then the pressure coming out at the end here, and then we have the airfoil in the middle with that mesh around it. Alright, so for this case, we're gonna do a viscous flow, which is already selected. You could also do inviscid. This is another part of the lab, but for the sake of this video, it's just gonna be the viscous flow. And then after that, everything looks good here. You wanna click on boundary conditions, and then on the inlets, you wanna open up this menu, just double click it, and then we're asked for a 60 Hertz motor frequency, and that's gonna equal to 12.56 velocity in meters per second. So that's what you're gonna put on here. If you're doing the 30 Hertz, then it's gonna be whatever that would equal. I think it's 6.1. So you just put that there, and then you click apply, and then you close. And then you can leave these alone. Yeah, we're good to go. So now you wanna double click on initialization, and then more settings. I like to keep it at 50 iterations because that always converges. I think the default is 10, but sometimes it doesn't converge. So that's done, and then you want to double click on calculations. I set it up to 100 iterations because why not? And it's just, the more iterations, the more accurate your results are going to be. You just click calculate. Alright, and then it's going to say complete. These are the residuals, and this is what the mesh looks like. I think it was there before. So for the problem, asks us to find drag force and drag coefficient of the airfoil. So you want to right click here on the report definitions, and then you hover over new, then force report, and then you click on drag here, and then you want to select the ellipse, which in this case the ellipse is the airfoil. It just renames it because it kind of, you already have it set from other calculations. So the ellipse is the airfoil pretty much. Then you're going to click compute. It's going to say 4.748 as the drag coefficient, and then you tabulate that. And then the force here, you can also compute, and then you're going to get this, and this is the drag force, obviously. So if you ever want to find something else like lift, you just do the same thing, and then you click lift, and then it's going to give you the lift pretty much. So that's how you get those. And then we're also asked to get contours for the pressure and velocity. So you're gonna double click on contours. We have pressure here, and you just select whichever pressure you're looking for. In this case, we're looking for total pressure, and then you save that and display it. This is the pressure. It's very red because of the streamlined body of the airfoil. You're obviously gonna have some differences here because it's viscous flow. So yeah, in this little weight region here. Yeah, but it mostly doesn't change. And then you want to double click on that again. You could save it if you want, or like screenshot it. And then you could click on velocity, and you want to not highlight that, because if you highlight that, it's just going to give you the surface one, and you just want the velocity magnitude for everything. And then here's the velocity as it goes through the air, the wind tunnel. The velocity increases, and then your two highest velocities are going to be right here when they're going over and under the airfoil. And yeah, that's how you find the velocity. And then they also ask you to find the streamline, the streamlines for the airfoil. And so for that, you're going to want to minimize this and then open up results. So this, when you first do your run, this is not going to be here. So you're just going to have this in the isometric view. It's going to look like this, and then you just want to go into whatever axis your wind tunnel is, you know, from left to right. And then you want to double click on this little, the one that says streamline here. And then it's going to give you the title. And then you want to start from velocity inlet, since you want the streamlines of the whole thing. You know, if you click something else, it might start from here, and just depends where you put that. So I like to do 50 points just because it's a little more accurate and you can see better. And you want to hit apply here, and then you're going to get the streamlines here. So it's going to give you the same kind of similar result as the contour, with the two highest velocities up here in the front of the airfoil, and then it increasing through the wind tunnel. That's pretty much it.